everyone, in this video let's discuss how to calculate the given target address in compiler design in this problem. So if you see, before going to calculation of target address, we must be needing the two basic understanding of the instruction formats and addressing modes. If you see in the instruction formats, we are having four. First one is format 1, which is of 1 byte. All of us know that 1 byte will be equal to 8 bits. 1 byte will be equal to 8 bits. So here complete 8 bit will be occupied by the opcode or operational code. Next, format 2, which is of size 2 bytes. 2 bytes means 2 into 8, because 1 byte is of 8 bits and 2 bytes will be of 8 plus 8, 16 bits. So here also 8 bit will be occupied by operational code, that is opcode. Next, register 1 will take 4 bits and register 2 will take 4 bits. Next, format 3 will be of 3 bytes. 3 into 8. 8 3s are 24. In that 24, first 6 will be occupied by the operational code and there will be registers like NIX, BPE. NIX, BPE. They will take 1 each. So total 6 plus 6 will be 12. So 12 is over. How much we had? 3 bits. 3 byte means 3 into 8. 8 3s are 24. In 24, 6 is here and another 6 is occupied. So left out is 12. This will be of the displacement, or you can call it as address. Next here, 4 bytes. So 4 bytes means 4 into 8. It will be 32. In this also 6 will be occupied by opcode and each one of them will be occupied by NIX, BPE registers, and the left out. How much is left out? 6 plus 6 will be 12. So 32 minus 12 will be 20. So 20 will be for the displacement, or you can call it as address. So in most of the exam you will be getting the problem based on the format 3 and format 4. Now let's move to the addressing modes. So if it is a simple addressing mode, the n value will be equal to I value, which may be 0 or 1. Here n value is there, here I value is there. When both n and I value will be same, that may be 0 or 1, you can call it a simple addressing mode and its target address will be displacement. Next, immediate addressing mode. Here only I value will be 1. Here only I value will be 1 and n value will be 0. In that condition, only displacement will be the target address. It will be the immediate addressing mode. Third one is indirect, in which vice versa. That is, I will be 0, n will be 1. So n value will be 1 and I value will be 0 in the indirect. Next, base relative. So in base relative, B value will be 1 and P means program counter value will be 0. Next, in program counter relative, base will be 0 and program counter value will be 1. That is vice versa. These two are vice versa, these two are vice versa, like that. Base value will be 0 and program counter value will be 1. So you will be adding displacement with its base value, because base value is 1. Displacement with its program counter value, because program counter value is 1. So one thing you must keep it in mind, in any question, it may be of the immediate, indirect, base relative, program relative or simple. So wherever 1 will be there, you will be considering it. If B value is 1, in simple means you will add base here. If program counter value is 1, you will add program counter here. But only one thing you must, but only E will be not be and but only E will be the exception. That is, when E value will be 1, you will not consider it. You must not consider E value when its value will be 1. So when it is 0, you will not consider as it is. But when its value is 1 also, you must not consider. So E is the exception except E. If all others are coming, for simple also, for immediate also. Immediate formula is displacement now. For immediate, while you are calculating, where if x value is 1 means, if x value is 1, so you will be adding x here, like that. You must add. So you must not add e. So hope you understood. Let's jump into the problem. Now let's start solving the problem. Here b value is given, program counter pc value is given, x value is given. Here h in the bracket represent hexadecimal values, so no need to confusion. Find the target address and the value loaded for the register. So value loaded for the registers, and they have given 3 of them. So h means hexadecimal. Let's solve one by one. Here they will be given the addressing map. Here they will give the addressing map. Using this, let's conclude and write the value loaded to the register. So how to solve the problem? First, you must know two power values, that is 2 power 0, 2 power 1, 2 power 2, 2 power 3. So why I said means because you will be representing them in the hexadecimal format. 2 power 0 means 1, because any value having 0 as its power, its value will be equal to 1. 16 power 0 will be 1, 18 power 0 will be 1, 100 power 0 will be 1, like that. 2 power 1 will be 2, 2 power 2 will be 4, 2 power 3 will be 2 to the 4, 4 to the 8. So using this, let's represent it. Now first one is 0, 3, 2, 6, 0, 0, h is not required. So how you will represent 0 in hexadecimal format? All will be 0. 0, 0, 0, 0. Next, how you will represent 3? 2 plus 1. So 0, 0, 1, 1. Next, 2. So 2 is already directly there. So 0, 0, 1, 0. 6 you must represent. 4 plus 2 will be 6. 0, 1, 1, 0. Next, 2 zeros means 0, 0, 0, 0, 0, 0, 0, 0. First 6 will be of the opcode 4 plus 2. So that is, this will be of opcode. This will be n value, n, I, x, b, p, e. How many are left? 4 plus 4 plus 4. 12 are left. So this 12 will be considered as the displacement. Which format is this in which 12 bits are of the displacement? It is format 3. Let's write it. So it is format number 3. If you see here, see the values. What are the values right here? N value will be equal to 1. I value will be equal to 1. If it is 0, don't write it. And here if you see, P value is equal to 1. When n value and I values are same, that is both of them may be 0 or both of them may be 1. Both of them must be same. When both n and I are same, you can call it as simple addressing mode. Simple addressing mode. And what is the target address for simple addressing mode that I have discussed earlier? Its formula will be displacement. And I also said a short trick that except E, what are the values having except E? Which of the registers having 1 as the value, they will also be considered. So P value is 1, so I must add P also. What is the displacement here? 0, 1, 1, 0. 0, 1, 1, 0 means 6. 0, 0, 0, 0 means 0. 0, 0, 0, 0 means 0. So 6, 0, 0 is the displacement plus P. So P means program counter value. It is given. That is 0, 0, 3, 0, 0, 0. If you add both of them, you will get 3, 6, 0, 0. Now for the first problem, you found the target address. What will be the value loaded to the register? So the value loaded to the registers will be equal to C3600. 3600 is here, and it is the simple addressing mode. So what is the value inside? It will be the value loaded to the register. So it is 103000. This is the value loaded to the register for the first problem. Now let's consider the second question. You will get it more easier. So 0, how you will represent 0? 0, 0, 0, 0 in the hexadecimal format. You must represent 2. 2 is here directly. So 0, 0, 1, 0. Again 2, 0, 0, 1, 0. Again 0 is there. 0, 0, 0, 0. Next 3. 2 plus 1 will be 3. So 0, 0, 1, 1, 1. Next 0. 0, 0, 0, 0. If you see here, first 6 will be considered as the opcode. Next N, I, X, B, P, E, and all others will be considered as the displacement. Here 4 plus 4 plus 4, 12 are the displacement bits, so that you can tell it as format number 3. This is format 3. Next, where and all the values are equal to 1 in this 6 registers. N value is equal to 1, P value is equal to 1. So this is not the simple addressing mode because N and I values are not same. N value is equal to 1. So when N value is equal to 1, you can call it as the indirect addressing mode. Indirect addressing mode, in that target address will be equal to displacement. So what is the short trick I have said? For the displacement, whatever the values are 1, you must add that one also. Here P value is equal to 1. So just add P value. This is the indirect addressing mode. What is the displacement? 0, 0, 0, 1, 1 means 3, 0, 0, 0, 0 means 0, 0, 3, 0 plus program counter value is 0, 0, 3, 0, 0, 0. So if you add both of them, you will get 3, 0, 3, 0. Now search for 3030 to write the register value, that is the value loaded into the register. But since it is a indirect addressing mode, 3030 you can't write 003600 directly. So what is the value inside? 003600. That is 3600 is the valid number, because whatever the zeros before non-zero element will not be considered. That is whatever the zeros after the non-zero digit will only be considered. So 3600 no. Search for 3600. 3600 is here. So its value will be loaded into the register since it is the indirect addressing mode. First you will search for this and search for the address, and you will search for that address location and again search for its address. So that value will be loaded into the register. The value is 103000. Here third one. How will represent 0? 0, 0, 0, 0. 1, 0, 0, 0, 1. Here 1 is there. So next 2 0, 0, 0, 0, 0, 0, 0, 0, 0. Next I must represent 3. 2 plus 1 will be 3. So 0, 0, 1, 1. Next again 0 is coming. 0, 0, 0, 0. First 6 will be of the opcode. Next this will be of N, I, X, B, P, E. And all these will be considered as the displacement values. So since there are 12 displacement bits, you can call it as the format 3. Format 3 only most of the question will be coming. Format 3, here where registers value is equal to 1, for only I value is equal to 1. When I value and N value are not equal, they can't be simple. When I value is equal to 1, it is immediate addressing mode. So it is a immediate addressing mode. So when it is a immediate addressing mode, what will be its target? Target address will be equal to displacement. Only the displacement value, because others are not having 1 here. Only I is having value as 1. So if you find the displacement 0, 3, 0. 0, 3, 0 is my displacement value. So what I will be doing, I will be searching this in the here outside for its location to find the value loaded into that register. 030. So 030 is not here. 3030 is here, but I need 030. Here 030 is not there. So you can conclude that the value loaded into the register for the third problem will be equal to the target address itself. That is 030 in the immediate addressing mode. Here, since there is no location to find its address, you can directly write the target address as the value loaded into the registers itself. So when there is a indirect addressing mode, you will go to its location or the address, and again you will search for its location or address in the memory. So hope you understood how to solve the target address calculation problem. If you have any doubt, please do comment below. I will clarify it. If you liked the video, please subscribe and support us. Thank you.